Hello everyone, welcome to the Chemical Safety Technology course. I am your instructor, Suo Yanbo. In this session, we will explore the classification of hazardous areas in explosive atmospheres. First, let us watch a video of an aluminum dust explosion incident.
Kunshan Metal Products Company, Limited. The 8-2 Extraordinary Major Aluminum Dust Explosion. Accident Summary of the accident. Kunshan Metal Products Company, Limited is primarily engaged in the manufacturing of hardware components, such as automotive parts and metal surface treatment and processing. Its main production processes include wheel grinding and polishing and electroplating. The workshop where the accident occurred was the wheel polishing workshop. The workshop spanning 2 floors housed a total of 29 production lines. Grinding and polishing are both performed manually. Operations generate large amounts of aluminum dust. The dust passes through the suction ports at each work station and enters the dust collection ducts. It passes through a mechanical vibrating bag house dust collector, where the dust is separated and the gas is discharged outdoors. The accident workshop is equipped with a total of 8 dust collection systems. Small exhaust pipes are interconnected and discharge into a single main duct at 7 a.m. on the 2nd of August, 2014. 265 employees were on duty in the accident workshop. At 7:10 a.m., the dust collection fans were started. At 7:34 a.m., an explosion occurred in dust collector number 1. The shock wave from the explosion traveled along the dust collection ducts into the workshop, raising the aluminum dust accumulated in the dust collection system and in the workshop, triggering a chain of explosions. As of the release of the investigation report, the incident resulted in 146 deaths and 95 injuries.
We can see that the consequences of this aluminum dust explosion, which occurred in 2014, were devastating. So, how are hazardous areas in explosive environments classified to enable targeted management? The primary standards for classifying hazardous areas in explosive atmospheres are the Code for Design of Electrical Installations in Explosive Atmospheres, Electrical Apparatus for Explosive Gas Atmospheres, Part 14, Classification of Hazardous Areas, Electrical Apparatus for Use in the Presence of Combustible Dust, Part 3, Classification of Areas where Combustible Dusts are or may be present, and the Electrical Safety Regulations for Explosive Hazardous Locations of the People's Republic of China. Explosive atmospheres include explosive gas atmospheres and explosive dust atmospheres. An explosive gas atmosphere refers to an environment where a mixture of flammable substances in the form of gas or vapor with air once ignited can sustain combustion and propagate on its own. An explosive dust atmosphere refers to an environment where under atmospheric conditions a mixture of flammable substances in the form of dust, fibers or fluff with air once ignited can sustain combustion and propagate on its own. The classification of hazardous areas in explosive gas atmospheres is determined based on the frequency of occurrence of explosive gas mixtures and ventilation conditions. Explosive gas atmospheres are classified into zones 0, 1, and 2. Zone 0 refers to an environment where explosive gas mixtures are present continuously or for long periods. Zone 1 refers to an environment where explosive gas mixtures may occur during normal operation. Zone 2 refers to an environment where explosive gas mixtures are unlikely to occur during normal operation or where they occur only for short periods. Normal operation refers to a working state or process involving normal startup, running operation, and shutdown. This naturally includes the removal of products from equipment as well as normal operations, such as opening and closing equipment, handling lids, feeding materials, removing impurities, and operating safety valves and drain valves. Abnormal conditions refer to situations where leaks or accumulations of explosive mixtures occur due to damage to containers or piping systems, equipment malfunctions, or incorrect operation, thereby creating a potential risk of explosion. With the exception of enclosed spaces, such as the internal gas spaces of sealed containers or storage tanks, Zone 0 is rarely found. Although mixtures above the upper explosive limit do not form an explosive atmosphere, environments where such mixtures could enter the air and reach the explosive limits should still be classified as Zone 0. For example, storage tanks for flammable substances with fixed roofs. When the space above the liquid level is filled with an inert gas, it may not be classified as an explosive, hazardous area. During design Zone 0 or Zone 1, areas should be minimized in number or scope through design or appropriate operating methods. That is, the majority of factories and other equipment installation sites should be classified as Zone 2 or non-hazardous areas. Under what circumstances can an area be classified as a non-hazardous area for gas explosions? First, areas with no sources of flammable substance release and where the ingress of flammable substances is impossible. Second, areas where the maximum possible concentration of flammable substances does not exceed 10% of the lower explosive limit LEL. Third, areas near equipment using open flames during the production process, or areas near equipment where the surface temperature of heating components exceeds the ignition temperature of combustible substances in that area. Fourth, open air or exposed sections of overhead pipelines transporting combustible substances located outside the production facility area. However, the classification of areas around valves is determined based on specific circumstances. The classification of hazardous areas in explosive dust environments is determined based on the quantity of explosive dust, its explosion limits, and ventilation conditions. Explosive dust environments are classified into zones 20, 21, and 22. Zone 20 refers to areas where clouds of combustible dust in the air are present continuously, for long periods, or frequently, in an explosive atmosphere. Zone 21 refers to areas where during normal operation, clouds of combustible dust in the air are likely to occur occasionally in an explosive atmosphere. Zone 22 refers to areas where during normal operation, clouds of combustible dust in the air generally do not occur in an explosive dust atmosphere. Even if they do occur, the duration is brief. Under what circumstances can an area be classified as a non-hazardous area for dust explosions? First, the area is equipped with a dust collection system that provides effective dust removal, and the process unit is capable of interlock shutdown when the dust collection system stops. Second, a blower room serving the explosive dust environment is provided and separated by a wall. The duct leading to the explosive dust environment is equipped with safety devices to prevent the ingress of explosive dust mixtures. Third, the amount of explosive dust used in the area is small, and operations are conducted within a fume hood or under a hood. How are explosive gas mixtures classified and grouped? According to the provisions of the National Standard Code for Design of Electrical Installations in Explosive Hazardous Environments, explosive gas mixtures are classified based on their maximum experimental safety gap, MISG, or minimum ignition current ratio, micro, and grouped based on their ignition temperature. Explosive gas mixtures with a MES-FG value greater than or equal to 0.9 mm are classified as Class IIA. Those with MES-MEG values greater than 0.5 mm but less than 0.9 mm are classified as Class IIB. And those with MES-MEG values less than or equal to 0.5 mm are classified as Class IIC. Explosive gas mixtures with a micro value greater than 0.8 are classified as Class IIA. Those with micro values greater than or equal to 0.45 and less than or equal to 0.8 are classified as Class IIB. And those with micro values less than 0.45 are classified as Class IIC. Explosive gas mixtures are classified into 6 groups, T1 through T6, based on their ignition temperature. The classification and grouping of common flammable gas, or vapor, explosive mixtures can be found in Appendix C of the Code for Design of Electrical Installations in explosive hazardous environments. According to the provisions of the National Standard Code for Design of Electrical Installations in Explosive Hazardous Environments, dust in explosive dust environments is classified into the following three categories. Class IIIA for combustible, flames Class IIIB for non-conductive dust, and Class IIIC for conductive dust. The characteristics of common combustible dusts can be found in Appendix E of the Code for Design of Electrical Installations in Explosive Hazardous Environments. In this lesson, we learned about the classification of hazardous areas in explosive atmospheres. We learned that explosive gas atmospheres are classified into zones 0, 1, and 2, while explosive dust atmospheres are classified into zones 20, 21, and 22. We also gained an understanding of the classification and grouping of explosive gas mixtures, as well as the classification of dust in explosive dust atmospheres. That concludes this session. For your homework, please consider the following question. Under what circumstances can an area be classified as a non-hazardous area for dust explosions? Alright, that concludes this session. See you next time.